We're doing question number 6 now. Question number 6 of area and perimeter on www.pslemath.blog. Here we go. We have before us a figure which is a rectangular piece of paper. That has a hole in it. You have a 4 cm square cut out of it. So this is a rectangle that is actually a piece of paper, and you have a 4 cm square cut out of it at the exact center of the paper. So what it means is, if the whole length of the rectangle is 24 cm and this is 4 cm, this 4 cm is right at the center. 24 minus 4 gives 20. So you must have 20 here. 20 divided by 2, you get 10. From here to here, the empty space is actually 10, which is here is 10 cm, and here is 10 cm. All right. And if this is at the exact center, that means it's here 4 cm here. So 18 minus 4 gives you 14. 14 divided by 2 gives you 7. So from here to here is 7 cm. From here to here is 7 cm. And the question asks you, what is the maximum number of 3 cm squares you can draw on the piece of rectangular paper? So it says maximum, means you can draw less actually. And what they mean is this: if you were to draw, for example, here, and then you draw another one here, can you see that the squares, you're not making full use of the space here? You can draw them closer together, closer to the edge of the rectangle, and that means more space. So how to do this question? To do this question, you got to ask yourself whether you can use the entire piece of paper. That means, can you draw the squares and they cover every square cm of the paper? It's not possible. What do I mean? Watch this. Imagine now this is a 5 by 4 cm piece of paper. How many 3 cm squares can you draw here? Well, you take up 3 cm here, you are left with 2 cm here. You can draw a 3 cm square here. There's no space for you to draw. So the answer for this is only one. You can only draw one 3 cm square. Now some students are confused. They say, I think I can draw 2. How do they do it? They say 5 times 4, the area of this rectangle is 20. And the area of one 3 cm square is 3 by 3. 3 by 3 is 9. And if I'm going to divide 20 by 9, I get 2 holes and 1 ninth. So at least I can fit 2 squares. Well, you can only draw those 2 squares if you cut up the 2 squares into rectangles. But that is not a square. So I repeat, you use 3 cm here, you are left with 1 cm. You can't draw a 3 cm square here. You can only draw a 1 cm square here, like that. And once you draw this is not a 3 cm square. Likewise, there's 2 cm here. You can't draw a 3 cm square here. Maximum size you can draw is 2 by 2. So understand that there is going to be space over here. Maybe there might be space that you cannot use. there might be space on this rectangular piece of paper that you might not be able to use to draw your 3 cm squares. You got to understand the concept first. How many 3 cm squares can you squeeze into 10 cm here? Well, you can draw 3, 3, 3, and then there will be a 1 cm here. A 1 cm here. It's only here that you cannot use, right? Over here you cannot use this part. I'm shading it green. You can't use this 1 cm by 4 cm here. You can't use it because you cannot squeeze a 3 cm square there. So let us see, in this rectangle, how many can you squeeze on 18 cm? Along the 18 cm, you can squeeze 18 divided by 3 is 6. So you have 1, 2, 3, 4, 5, 6. Right? So if we're gonna draw them, it's like something like that. Can you see? So how many squares can you squeeze in here? 1, 2, 3 by 1, 2, 3, 4, 5, 6. 3 times 6, you get 18 3 cm squares. You can squeeze here, which is going to be the same here because this is the exact same dimensions over that side. So again, you have 9 cm that you can use here. 9 cm. And it's only this part here that you cannot use. You shade it out. And the same thing, you can draw 18 squares, 18 3 cm squares can be fitted in here. Okay, so this is like 3, 3, 3, 9 cm. Can you see? We are only using 9 out of the 10 cm. And here's 3, 6, 9, 12, 15, 18. We are using everything. We're using everything along the breadth. So we are left with, you agree we cannot fit a 3 cm square here. What about here? From here to here is 7 cm. 7 cm, well, I only can fit in 6 cm. So this cannot be used. 1 cm here cannot be used. So your dimensions now over here, okay. From here to here, how many cm is it? Well, let us see. This is 4 cm. 4 cm. This is 1 cm. 1 cm. 5 cm. 6 cm. So from here to here is actually 6 cm. 6 cm. And we have already removed 1 cm from here, remember? So this is 3, 3. This is 6 cm also here. You can fit 4 squares here. 3, 3 is 6. 3, 3 is 6. So you have 4 squares here. And the same is true for below. Below is the same is true. You cannot use this part here, but you can fit another 4 squares here. So how many squares can you draw? How many 3 cm squares can you draw? What's the maximum number? Well, the maximum number, you have 4 here, 4 here. 4 plus 4. That's 8. Then remember we have 3 times 6 is 18, and plus another 18, you get 36. 36 plus 8 is 44. You can draw the maximum number of squares, 3 cm squares you can draw is 44. And you can't use this space here. Of course, you can't use the one here because it's a hole. You cannot draw in a hole, please. You cannot draw in a hole. If you can, you would be a magician. Alright, think about it. If you find that you don't understand this question, I want you to take a piece of paper. You take a piece of paper and you draw, try to draw a 24 by 18. I think an A4 size paper would be, it's possible for you to cut out. And then you really draw the 3 cm squares. Find out how many can you squeeze in. Not squeeze in, how many you can draw. What's the maximum number you can draw? Okay, that's the answer for question number 6.